Okay, so we are back and we are doing lesson 5.6, which is called All for One and One for All. Okay, so remember all the constraints that um, Clarita and Carlos went through. And so you can see here that the space, remember, 6 feet for the cats, 24 feet squared for the dog runs. They only have 360 feet available. The startup costs, they only had 1,280, and it cost this much for cats and this much for dogs. And then there was a feeding time, right? Like Carlos and Corita realized that they had to feed the animals twice a day, and cats took longer because they had to also clean out their litter boxes, same with dogs and whatever. Actually, cats didn't take longer. Okay, and then pampering time, and I think that was Clarita's job because she had the middle part of the day where Carlos did not have the middle part of the day. So they want you to write a system of inequalities that model these constraints, and we've already written these, so this is not going to be new information to us, but I do want to write these all out. And actually, I'm going to write these. Nah, I'll write these here. So I'm going to use cats. C for cats. So this is for space. For space, we had 6C plus 24D is less than or equal to 360. And then for money, right, it was 32C, right, plus 80D is less than or equal to $1,280, right? And then moving right along, I think this was feeding. The next one was feeding, right? So feeding was, yeah, there it is. It was 6C plus 12D is less than or equal to 480. And this is because we're using minutes. And then last but not least, we have pampering, which was 16C plus 20D is less than or equal to 480, right? So this was our system of inequalities. This is all of our constraints put together. And when we think about constraints, we think we have to meet these. And so Carlos and Clarita have all these different combinations that could possibly work based on their constraints. Okay. So the next part, it says our focus is going to be by the end of this lesson, you will be able to find the solution set for a system of linear inequalities. You already know how to do this. Okay, so all we're going to do today is we're going to put them all together. We're going to put the space and the money constraint and the time constraints for pampering and feeding. Okay, we're putting those all together. So the question you'll be able to answer today is, how do I represent these solutions that satisfy all the constraints being placed on a context? Now, it says the word all, and I want to remind you what all actually means. It means if it meets the space requirement, but it doesn't meet the money requirement, that's not a good combination of cats and dogs. Okay, it must meet all four of these kind of like criteria. All right, some more context. Carlos and Clarita have found a way to represent the combinations of cats and dogs that satisfy each of their individual pet sitter constraints, but they realize they need to find a combination that satisfies all of their constraints simultaneously. Now, why? Right? And we kind of just talked about that. So, first, begin by listing the system inequalities that you have written to represent the startup costs and space. The startup costs and the space from pet sitters. Okay, so that's the very first set. So now we're only going to take these first two equations from up here, and we're going to bring them down here because they only wanted us to talk about the startup costs. The startup costs was in what color? So the blue. Okay. So that was this, and so here's the cost. So that was 32C plus 80D is less than or equal to 1,280. And then we had the space constraint, which was 6C plus 24D is less than or equal to 360. Okay. Then it says this is number 2, find at least 5 combinations of cats and dogs that would satisfy both constraints represented by this system of inequalities. How do you know that these combinations would work? And we've already done this, right? Some of you came up with really, really good combinations. And the way you're doing this is you're checking to make sure that that's actually true. Now, we could do this on Desmos, of course, but I want to just put a couple combinations out there for you so that you understand how this works. So, what do you think about 10 cats and 10 dogs? Because I like multiplying by 10. I'm going to try the point 10 10. So I'm going to try 10 10. And what I'm really looking for, that it works for both of them. Okay. So that's 320. Oops, sorry. Let me tell you, times 10 plus 80 times 10. Is that less than or equal to 1,280? So that's 320 plus 800 is 1120, is definitely less than 1,280. So here it works. And some of you are like, Miss Johnson, can't we just plug this into Desmos calculator? Absolutely. But I do want to do this by hand so everyone sees that you can check this. So it works for the bunny side. I'm going to check if it works for the space side. So 6 times 10 plus 24 times 10. Is that less than 360? So that's 60 plus 240. That's 300, which is definitely less than 360. So we're good here. So Miss Johnson, she's happy. She's happy because she found 1 point. So your job right now is to find 4 more combinations of cats and dogs, numbers of cats, numbers of dogs that would work for the cost and the space constraint. So go ahead and work on that. They should get checks for both of them. If you want to see me do it on Desmos, I will show you here so you guys can see it. I'm just going to plug in over and over again. So 32 times 10 plus 80 times 10. Yay, that's 1120. And then for the other one, I'm going to go 6 times 10 plus 24 times 10. And that's, did I do that right? Yeah, that's right. It's 300. Making sure that I always plug in my numbers right, because Miss Johnson, sometimes she forgets and she plugs in numbers wrong, right? Okay, so that's done. So what I need you to do is check 5 more combinations. Now, your 5 combinations don't have to necessarily be different numbers. Think about this. You want to choose numbers that will work. Okay? So I'm expecting to see a list of numbers that would go here that would all work. Now you're going to fill that out on your Desmos activity. And so I'm going to look for those 5 when I'm grading them, because I really want to make sure that you had enough time to check these. So check out some of them. You can even go back and look at if you, whatever those were for the last time. Okay. Now it says list at least 5 combinations of cats and dogs that would satisfy one, but not the other. So Ms. Johnson, you want me to find a number of cats and dogs that it would work for, say, it would work for this side of space, but not this side for money. Is that what you're saying? Yeah, or vice versa. It has to work for one, but not the other. Okay. So let's see. If you were in class right now, I would ask, okay, well, what numbers would work? And so I'm just going to change one of these numbers and see if I can kind of think about this. Let's see. Now um, I'm looking at this right here, right? And I see that if I add one more dog, no, you'd still be okay, huh? Yeah. Okay, so if I add 2 more dogs here, 160, we'd be okay over here, and we'd still be okay over here. Okay, so if I add 3 more dogs, oh, I'm going to have to do this a little bit differently, huh? So I'm looking for a combination of dogs and cats that don't work, that one of them would work and one of them wouldn't work. Does that make sense? Okay, so go ahead and think about that for just a second. Okay, so I'm going to try the number. Let's see. If I added more of these, okay, I think I figured this out. If I add more cats for this combination, how many more cats would I need to add? Let's see, 60. So another 10. So that would be too much, right? So then if I did 20 comma 10, but that's too much over here. So maybe like 18. I'll try 18. I'm just going to play on my Desmos calculator and see if that works. So I'm looking for a set that doesn't work and works. So I'm going to change cats to like say 19. I know 20 doesn't work, so I'm going to try 19. Oh, okay. So look at that. 19 works for this one, but it doesn't work for this one. Okay. So one of my combinations that doesn't work is 19 cats and 10 dogs because it works for the space, but it doesn't work for cost. Okay. And you can continue playing with these numbers just to find more. Again, I am going to be looking for another set of numbers on your Desmos that you are showing me that works for four more combinations that would work for one, but not for both. Then it says shade a region on the coordinate grid that represent the solution set for the system of inequalities and explain how you found that region to shade. So what we're doing here now is we're basically going to be graphing this thing, which you guys already know how to graph an inequality. Okay, so let's bring that up. Let's bring Desmos. Where are you, Desmos? And let's graph these two things. So we get 32x, and I'm changing it to x plus 80y is less than or equal to 1,280. And then the second one is 6x plus 24y is less than or equal to 360. Okay, and we get these two. Okay, so that's why if you notice, like, can you look for this point? Look for your points right now. Look for your points here. Where are they on this graph? Okay, I'm going to kind of copy this graph over here. If I had a couple more helpers, I would be able to like snip this and then add it, but I don't. So I'm going to be taking this by hand. So I'm going to go, this is cats. This is dogs. And then I'm just going to make 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to make this 20. So each one goes by 2. And then same thing goes with this side. 2, and then 2, 4, 6, 8, 10. This is going to be 10, 2, 4, 6, 8, 20. Okay, and then I'm just going to graph this thing really quick. So for the blue guy, and I'm going to try to use the same colors so that it helps you like imagine this. For the blue guy, I get 15. So 2, 4, 6, 8, 10, 12, 14, 16. So right in the middle here. And then the slope, that goes all the way out to what? 10, 20 to 20. So that goes all the way out to here, and that's a solid line. You should know what that solid line means. Oops, I missed it a little bit, but that's okay. And then so that gets graphed. I'll go grab that blue one later. And then let me grab the green one. The green one is at 16. So I don't have a green, so I'm going to use this. Let's see. I'll just use this black. No, I guess I'll use pink. Sorry. So 16, and then it goes all the way to 15. So right here, and so it goes like, right, something like this. It's not perfect. My graph is not perfect by any means, but then this guy gets shaded here. You guys all see this. And then let me shade in blue so you guys see how this matches. Right, you guys all see how this goes. And what do you notice? Okay, first you should notice that Miss Johnson doesn't know how to color. That's what you should notice, right? Right. You should notice that there's a section that's colored twice. Now it's better shown here because they have way better coloring things here than I do. Right. Oh, and that's not even blue. That's purple. What the heck? Okay. So moving on. So that's what you get. You should ask yourself, how did you know which region to shade? Like, how did you know to shade below it? How did the calculator know to shade below it? Now, the calculator is only going to help you do what you already know how to do. I'm going to ask you the questions like this. This is a classic Miss Johnson question. Explain how you knew which side to shade. And some of you are like, oh, but Miss Johnson, isn't it obvious because it says less than, so it should be below? And the answer is yeah. That's exactly the reason why I'm shading below. All right, let's move on. It says rewrite your system of inequalities to include the additional constraints for feeding time and pampering time. I'm not going to write them. They're all the way at the top. You can see them. And these are the notes here. You can, you already know, you guys know where to find my notes. So I don't know why I did that. Okay, so you'll see my notes for you. Don't worry. And then it says find at least 5 combinations of cats and dogs that would satisfy all the constraints represented by the new system of inequalities, right? So now this is the part that you are trying on your own. Uh-oh, something happened. Or I can't draw anymore. Uh-oh, hold on. Let me X out of there really quick and open it up. Okay, so now they want you to find 5 there it goes. 5 combinations of how you of ones that would work and ones that wouldn't, and then 5 combinations that would work for some but not all. And then it says shade the region. So I'm gonna actually shade the region first. So I'm gonna go all the way back up to the top where I had all of my equations. Where are they? There they are. And I'm gonna add them all in here. So I'm gonna add 6x plus 12y is less than or equal to 480. And then I'm going to add 6x plus 12y is less than or equal to 480. And then the other one is 16x plus 20d, or which is 20y, is less than or equal to 480. Okay, make sure that I copied those correctly. And then I have this huge graph here. You guys all see it? Let me maximize that really quick. Look at that. That looks like a mess. Does everybody see that? That looks like a mess. Okay, so things that you should notice is that there are certain sections, maybe like here, like if you were to choose one of these points, and this is what I want you to go through. What if I plugged in 2020? This point right here. Let me actually plot the point 2020. If I plugged in the point 20, comma 20, right? Do you all see this point right here? What would happen? Algebraically, what would happen back here? Would it fall under one of the points? Would it fall under 6 or would it fall under 7? 2020. Would 2020, that this point right here, would that fall under 6 or 7? Go ahead and vote. I'm pretending that you guys are in class. What would you say? Write down your answer. Okay, now what do you think? Yes or no? Would it fall under 6 or 7? So if you said 7, you're right. Because if you notice, it is not in the shaded region for all of them. It is not in the shaded region for all of them. So here, now that you know how to do this, they want you to pick numbers up here that would work for all of them. Where is that region? Where is that region? Okay. If you had to draw that region, what does it look like? Okay. So I'm going to try my best to copy this, and it's really dark, so it's kind of funny looking. So I would definitely draw this region. I'm going to look at where all the numbers are. So I'm going to start at 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I'm going to start at 15 and I'm going to travel until I hit that point right there. You see that point right there? I don't know what point that is, but it's some point. And then I get on the green one. So first I travel along purple, and this is just a sketch. So I'm traveling along purple, and then I'm going to get to the green guy. So I'm going to travel along the green guy. So I'm going to pretend I don't have green on my little list here, but maybe I can change this guy. Let me change this guy for green. Oh, look, now I have green. Okay, so I'm going to travel along the green guy. Do you guys all see that? It doesn't look like this. This is bugging me. Hold on. So maybe like this. Is that better? Sure, why not? And then I get to this guy, which I think is red or orange. Yeah, that's red. I don't have red. Somebody use this dark pink. So then I use this dark pink. Let's see, there. And then I go all the way down to the, what number is that? So that's 50, so 30. So whatever, this goes down to 30. And I'm just going to write this as 30. Do you guys all see this region right here? This is my solution set. This set here, which, let me see. Oh, I can annotate on top of here. Let me annotate. I cannot annotate because I'm using my iPad. All right. So all of this region here, I'm going to follow this blue part here to the, see how this is a green line here? To the green line here, to this here. Now this doesn't look like that at all, but do you understand what I'm saying? It goes from here to here to here. Ms. Johnson, that's 3 of them, but you wrote 4 of them. How come you only wrote 4? You tell me. You tell me why I didn't include that 4th one. Okay, while you do that, I'm going to shade my solution region, all this. This is my solution region, meaning any point that I choose here in this dark, dark, dark section from here all the way to here, traveling up to red, traveling along the green, traveling along the blue, these points meet all the conditions. You see the word all right there? All. Okay, so if you were trying to find answers for number 6, you're choosing anybody from this darkest region. If you're trying to find anybody for number 7, that not all of them would work, right? Then you're choosing from not that dark region. So maybe like where this point is. Okay, so we're going to play a game and you're going to say number 6 or number 7. Okay, you're going to say, yes, it's a solution, or no, it's not. Okay, so what if I pointed right here? Yes or no? Yeah, so for those of you who said yes, good job. Ms. Johnson, it's in the darkest region. It meets all 4 conditions. Exactly. What about right here? And people would say, no, because it didn't meet the green and the purple condition, right? It didn't meet the green or the purple. Okay, then I say, okay, well, what about right here? And you're like, yes, Miss Johnson, but it didn't meet the red condition. It didn't meet the red condition. It meant green, purple, and black, but it didn't meet red. So if it doesn't meet all of them, Miss Johnson, then it's not a solution for Carlos and Clarita. Exactly. Now here's a tricky one. Pay attention. Are you ready? What about this point right here, which I don't know what it is. So let me zoom in. What about that point right there? You see it? This point right there. What is that point? I want to find out what that point is. So that's 20, comma. I think that's 20, comma 8. So let's put that in. Oops, I'm trying to control my iPad from my thing. 20, comma 8. Yeah, that point. What about that point? Yes or no? Yes or no? So this is where I'm going to leave you hanging. I am not going to tell you. I will give you a hint, hint, nudge, nudge, wink, wink. I wish there was a way for me to tell. I wish there was a way for me to tell whether 20, comma 8 is a solution. Okay, so I'm going to write that down. I'm going to write that one down here. And we're going to say, is 20, comma 8 a solution? That is a good question. So again, this is one of those opportunities for you to include this answer into your flip grid. And actually, if you tell me if this answer is or is not a solution correctly and you explain it with precision, I am willing to give you guys extra credit on that, especially when you guys do the thing where you explain. All right, we're going to move on. Shade a region in quadrant 1 of the coordinate grid that would represent all possible solutions. We just did that. This set of points is referred to as the feasible region. Everyone say feasible region. Look at this over here. This is our feasible region. Ms. Johnson, why did they say quadrant 1? Like, what about this guy over here? So are you saying negative, I don't know, 5 comma 0? Yeah, I don't know what a negative 5 cat is. I don't know what that means. Do you owe me a cat? Are they, we talked about funny ideas about this, but so no, that's why they're only cutting it off with whole numbers. Okay, and since Carlos included can feasibly board any combination of cats and dogs represented by the points in this region without exceeding any of their constraints on time, money, or space. Okay, so this point right here is a solution. This one, this one, this one, no, 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 no. And this is the one at question. I wonder why we're questioning him. Okay, so we're going to move on. Okay, last question. How is the feasible region shaded in problem 9 different from the solution set of the system inequalities shaded in problem 8? So how is it different? How is this right here, what I have graphed here, including all this quadrant 2, quadrant 3, quadrant 4, different than what we graphed here in quadrant 1? Why is it different? Okay, so the real answer is what we just explained, because when we bring it back into the context, negative 5 cats doesn't make sense. So we restrict it to the first, we restrict it to the very first quadrant. Give me 1 second and then we're going to go over the takeaways. Okay, so this is, we're going to go over takeaways. So it says to find a solution for a system of inequalities, right? How did we do that? So the first thing that we did was we graphed it on Desmos, which you do need to know how to do it by hand. And there's several reasons why you need to know how to do it by hand. But you already know how to graph a line. So now we were just talking about which side we were shading. Why are we shading above? Why are we shading below? And if you think about Miss Johnson, she's always asking you questions to figure out if you know how to do something without the calculator that the calculator won't be able to answer for you. Okay. So you can shade the solution set for each individual inequality in the system. Remember, we did the first two, and then identify the overlapping regions. The other way to do it is if, and I'll show you at the same time here, the other way to do it was if we were to graph them, kind of like, shoot, I need those equations and I don't have them handy again. Oh, here they are. I can graph them. I can graph the boundary lines. Like what, Miss Johnson? I can go 32x plus 80y is equal to 1,280. Okay. And when I do this, right, do you see when I do this, it gives me it splits my little Desmos graph, right? And now your job is to figure out, do I shade above or below? But at the same time, I would do all of them. So let me do that really quick. So 6x plus 24y is equal to 360. And then we had 12x plus 20y is equal to 480. And then last but not least, we had 16x plus 20y equals to 480. Okay, so you have this whole thing, remember, and this is that shaded region. This is that shaded region we were talking about here, right? So then you would go in and you would start picking points. Like say, for instance, I don't know, I think we said a good point was 10 comma 10, like 10 comma 10, see where he is in the region. And then I would plug him into all of our inequalities, right? I would plug him into all of our inequalities and check to see if that is a valid solution, if it made a true statement, right? And then, of course, for this one, already know the answer. It's yes, because we've already checked it, right? So the thing that you always want to fall back on is, which side do I shade? Pick a point and plug it in. Okay. The next part says to define the feasible region for a system of constraint that models a context, all you would have to do is find the points of intersection, right? Here's all the points of intersection. This guy right here, this guy right here. Do you guys all see points of intersection right here? And this is the one that we said, is 20 comma 8 a solution? That's what you're supposed to find. To determine the vertices of that polygon. And if you notice, this is a polygon right here, right? Has one side, two sides, three sides, four sides, and then five sides. So this is a pentagon. It doesn't look like a pentagon. A pentagon just means five sides. Okay, moving on. So it says the graph of a compound inequality in two variables with an and represents the intersection of the graph of the inequalities. The cost has to be true and the space has to be true. That's what they mean by the word and. A number is a solution to a compound inequality combined with the word and. And if the number is a solution to both inequalities where the regions overlap, like in this case, it looks like the regions overlap here. In a system of inequalities, the word and is implied because the solution set must work for all equations, for each equation. Remember, we kept saying all the equations, this one, this one, this one, and this one, right? The feasible region is the region on the graph containing all the points that make all the inequalities in a system to be true at the same time. The feasible region for the solutions to the systems of inequalities is a location where the blue and the green regions overlap. Again, this is our feasible region. So questions that I have for you, what about these people on the border? Are they solutions? So this is, again, another opportunity for you to wrestle, like, are those solutions? I will tell you, but right now I want you to think about, are those solutions? And if you remember, put those in your flip grid so you guys can earn some extra points. Okay, the solution set for the system of inequalities is all of the points that satisfy all the inequalities in a system simultaneously or all together. Remember, we keep using this word, they have to satisfy all those conditions. Okay, so this makes sense to you. Okay, don't be like, oh my gosh, Miss Johnson, this is so hard. I really want you to think, what is the new thing that I heard today? What is the thing that might trip me up on my ready, my set, my go? Make sure you attack those things and don't let them like fester and say like, oh, these are things I don't understand. So let's look at our exit ticket. Looking at this, you're like, oh, I know how to do this. So here you're going to have to show me that you understand it here. So thank you so much for listening. I hope you all understand this and enjoyed this. Make sure you ask questions to your neighbors. Have a great day.